what is scalar product or dot product, and what is vector product or cross product, one by one. So let us discuss about scalar or dot product of two vectors. The scalar or dot product of two vectors is defined as the product of magnitude of two vectors and the cosine of the angle between them. Okay, the scalar or dot product of two vectors is defined as the product of magnitude of two vectors and the cosine of the angle between them. Okay, here scalar or dot product of two vectors is nothing but it is a way of one of the way of multiplying two given vectors. Here you can see in the diagram we have two vectors here, vector A and vector B. Now if you want to calculate the scalar or dot product between vector A and vector B, so how you will calculate is that the scalar product or the dot product between vector A and vector B is equal to, it is the product of magnitude of vector A and B. A and B is there, no, here it is product of vector of A and B and as well as the cosine of the angle between them, cos theta. Theta is nothing but it is the angle between vector A and vector B. So this formula, this expression will give us the scalar or dot product of two vectors. The scalar or dot product of two vectors can be defined as the product of magnitude of two vectors. Okay, we have to do product of magnitude of two vectors and the cosine of angle between them. ಅವೆರಡು ವೆಕ್ಟರ್ಗಳದ್ದು ಪ್ರಾಡಕ್ಟು ಮತ್ತು ಅವೆರಡು ವೆಕ್ಟರ್ಗಳ ಮಧ್ಯೆ ಇರುವಂಥ ಆ್ಯಂಗಲ್, ಕಾಸ್ ಆಫ್ ದಟ್ ಆ್ಯಂಗಲ್ ವಿಲ್ ಗಿವ್ ಅಸ್ ದಿ ಸ್ಕೇಲಾರ್ ಪ್ರಾಡಕ್ಟ್ ಆರ್ ಡಾಟ್ ಪ್ರಾಡಕ್ಟ್. ಸೊ ಇಫ್ ಯು ವಾಂಟ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದಿ scalar or dot product between any two given vectors, and it will be written as vector A dot vector B, which will be equal to magnitude of both vector A and vector B, which is multiplied by the cosine or cos of the angle between these two vectors. So this we will call it as scalar or dot product of two given vectors. Now examples of a scalar product. Okay, we can see here. Okay, examples of scalar product. Okay, this work is there. No, work is an example for scalar product, we know that. And also power, it is also an example for scalar product. You can observe here the product of dot product or scalar product, whatever the resultant you will get, no, that will always be a scalar quantity. You can see here we have two vectors here, force vector and displacement vector. These two are vector quantity. When you calculate the dot product between any two vectors or scalar product between any two vectors, it will be a scalar quantity only. Result will be scalar quantity only. You can see in the first example here. Okay, we have two vector here, force vector as well as displacement vector. If you calculate the dot product or scalar product between force and displacement vector, you will get this Fs into cos theta. Fs into cos theta is nothing but it is the dot product of force as well as the displacement vector, and resultant will be work done is nothing but it is a scalar quantity. So that is why the result of scalar product or dot product between any two given vectors will be a scalar quantity. ನೀವು ಯಾವುದೇ ವೆಕ್ಟರ್ಗಳಲ್ಲಿ ಯಾವುದೇ ಎರಡು ವೆಕ್ಟರ್ಗಳ ಮಧ್ಯೆ ನೀವು ಸ್ಕೇಲಾರ್ ಪ್ರಾಡಕ್ಟು ಅಥವಾ ಡಾಟ್ ಪ್ರಾಡಕ್ಟನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ರೆ ಆ ರಿಸಲ್ಟಂಟ್ ಬರುವಂಥದ್ದು ಏನಾಗಿರುತ್ತೆ ಅಂದರೆ ರಿಸಲ್ಟ್ ಆಫ್ ಬೋತ್ ಸ್ಕೇಲಾರ್ ಪ್ರಾಡಕ್ಟ್ ಆರ್ ಡಾಟ್ ಪ್ರಾಡಕ್ಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ another scalar product only, another scalar only you will get. And one more example you can see here, power is force into velocity here. Okay, force into velocity, and if you calculate the dot product between force into velocity, Fv cos theta, this is nothing but scalar product or dot product. So here also you can observe here the dot product between force and velocity, both are vector. So dot product between force and velocity will always give scalar quantity, which is power. Clear? So this is how scalar product or dot product. Now we will see geometrical meaning of scalar or dot product. A dot product can be regarded as the product of two quantities. Already we have seen what is the meaning of scalar or dot product. Now we will see what is the geometrical meaning. Okay, a product or a dot product can be regarded as the product of two quantities. Okay, it is regarded as product of two quantities. which is regarded as product of two quantities. Scalar or dot product can be regarded as product of two quantities. ಅಂದರೆ ಸ್ಕೇಲಾರ್ ಆರ್ ಡಾಟ್ ಪ್ರಾಡಕ್ಟ್ ಅಂದರೆ ಅರ್ಥ ಏನಂದರೆ ಇಟ್ ಈಸ್ ದ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ಟೂ ಕ್ವಾಂಟಿಟೀಸ್ ಅಂತ ಅರ್ಥ ಮಾಡ್ಕೊತೀವಿ. ದೆನ್ ವಾಟ್ ಆರ್ ದೋಸ್ ಟೂ ಕ್ವಾಂಟಿಟೀಸ್? ದೆನ್ ಒನ್ ಕ್ವಾಂಟಿಟಿ ಈಸ್ ದಿ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ ಒನ್ ಆಫ್ ದಿ ವೆಕ್ಟರ್. ಓಕೆ, ಇಟ್ ಈಸ್ ದ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ಟೂ ಕ್ವಾಂಟಿಟೀಸ್. ಸೊ ಅದರಲ್ಲಿ ಒಂದು ಕ್ವಾಂಟಿಟಿ ಯಾವುದಂದರೆ ದಿ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ ಒನ್ ಆಫ್ ದಿ ಗಿವನ್ ವೆಕ್ಟರ್, ಆ್ಯಂಡ್ ಸೆಕೆಂಡ್ ಕ್ವಾಂಟಿಟಿ ಈಸ್ ದಿ scalar component of the second vector along the direction of the first vector. ನಾವೇನು ಅರ್ಥ ಮಾಡ್ಕೊಂಡ್ವಿ? ಸ್ಕೇಲಾರ್ ಆರ್ ಡಾಟ್ ಪ್ರಾಡಕ್ಟ್ ಅಂದರೆ ಇಟ್ ಈಸ್ ದಿ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಆಫ್ ಟೂ ಕ್ವಾಂಟಿಟೀಸ್. ಅದರಲ್ಲಿ ಒಂದು ಕ್ವಾಂಟಿಟಿ, ಫಸ್ಟ್ ಕ್ವಾಂಟಿಟಿ ಏನಂದರೆ ದಿ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ ಒನ್ ಆಫ್ ದಿ ವೆಕ್ಟರ್, ಆ್ಯಂಡ್ ಸೆಕೆಂಡ್ ಕ್ವಾಂಟಿಟಿ ಏನಂದರೆ ದಿ ಸ್ಕೇಲಾರ್ ಕಾಂಪೋನೆಂಟ್ ಆಫ್ ದಿ ಸೆಕೆಂಡ್ ವೆಕ್ಟರ್ ಅಲಾಂಗ್ ದಿ ಡೈರೆಕ್ಷನ್ ಆಫ್ ದಿಸ್ ಫಸ್ಟ್ ವೆಕ್ಟರ್ ವಾಟ್ ವಿ ಹ್ಯಾವ್ ಕನ್ಸಿಡರ್ಡ್. ನಾವು ವಿ ವಿಲ್ ಸಿ ಟೂ ಎಕ್ಸಾಂಪಲ್ಸ್ ಹಿಯರ್. ಓಕೆ, ವಿ ಹ್ಯಾವ್ in the first example I have vector A and vector B, and they are separated by angle theta here. Okay, now if you want to calculate the scalar or dot product between vector A and B, let us see how we will calculate. Vector A dot vector B, which is equal to A into A means it is product of first vector, which is here in this example I will consider vector A as the first vector. Product of first vector into scalar component of the second vector. Scalar component of the second vector means b cos theta. Here I am calculating the scalar component of second vector in the direction of the first vector A. So and that means that vector A dot vector B, which means that scalar product between vector A and B is equal to magnitude of first vector A into scalar component of the second vector B with respect to first vector or along the first vector. Similarly in second case, here again dot product or scalar product between vector A and vector B can also be calculated as the angle between, which means that this also you can take it as the first vector, the scalar component of the second vector along the direction of the first vector, which is multiplied by the product of the second vector. So generally or overall if you can understand about the scalar or dot product, it is the product of two quantities. Those two quantities may be the magnitude of one of the vector, and second quantity is the scalar component of the second vector along the direction of the first vector. So this is what the geometrical meaning of scalar product or dot. Let us have a discussion on properties of scalar or dot product. Among that first property, the scalar product is commutative, which means that if you calculate A dot B, which means that scalar product between vector A and B is equal to product of magnitude of both the vectors as well as the cosine of the angle between. And similarly B dot A is also BA, which means that product of magnitude of vector A and B and cosine of the angle between. So that proves that A dot B, vector A dot vector B is equal to vector B dot vector A. Both will give us the same answer. So that is why the scalar product is commutative property or commutative it is. It obeys the commutative property. Commutative property is nothing but if any two given vectors follows this rule, which is dot product between vector A and V is equal to dot product between vector B and vector A. A dot B is equal to B dot A. That is what the commutative. Now properties of scalar product, second property, which is the scalar product is distributive over addition. Okay, the scalar product is distributive over the addition. So if the dot product or scalar product between any two given vector satisfies this relation, then we can call those product as the distributive over addition. Okay, dot product between vector A and sum of vector B plus C is equal to dot product between vector A and B plus dot product between vector A and C. So this is what the distributive property of a scalar product, which means that scalar product or dot product obeys the distributive property. Now the scalar product of two perpendicular vector is 0. the scalar or dot product between two perpendicular vector is 0. If these two vectors are perpendicular, let us have a look at this. We can call this as vector A and this as vector B. If the angle is 90, that means that cos theta becomes cos 90. The value of cos 90 is 0. That is why the dot product between two perpendicular vector is 0. Now fourth property, the scalar product of two parallel vectors is maximum and positive. Okay, the scalar product of two parallel vectors is maximum. So when both the vectors are parallel, we can see, then angle between them is 0. So that means that in the formula A dot B, AB cos theta, so cos theta becomes cos 0. Cos 0 means 1, which means that dot product between vector A and vector B is equal to, then it is the product of magnitude of both the vectors. This is the maximum value when both the vectors are parallel, and dot product or scalar product between those two vectors will be maximum. Fifth property, the scalar product of two antiparallel vectors is negative. Angle between two antiparallel and collinear vectors is negative, which means that angle between two antiparallel collinear vector is 180. 180 means it is minus 1, cos 180 is. So dot product between, dot or scalar product between vector A and vector B is equal to AB multiplied by minus sign. And the scalar product of vector with itself is equal to the square of its magnitude, which means that dot product of two similar vectors or two same vectors, or you can also say that scalar product of a vector with itself is equal to the square of its magnitude. Okay, if you calculate the vector product with itself, then the angle between both the vector will be 0. There is no angle. So that means that it becomes dot product or scalar product between vector A dot vector A is equal to A square. That is the square of its magnitude. Now the scalar product of two same unit vectors is 1. I repeat, the scalar product or dot product of two same unit vectors is 1 and two different unit vector is 0. Okay, see here, first let us talk about the scalar product between two same unit vectors, I dot I cap, which is equal to j cap dot j cap, which is equal to k cap dot k cap, which is equal to, because we know that, so dot product or scalar product between any two given vectors is the product of magnitude of both the vectors. Here product of magnitude of both the vector means magnitude of unit vector is 1, here also 1, so 1 into 1, and the angle between both the vector, which is 0, because I also represents x-axis. If you assume it as I also represent one x-axis, and both I dot I, so both will represent I-axis itself. So that is why the angle is 0 between I cap and I cap. So that is why the scalar product of two same unit vector is always 1, and the scalar or dot product between two different unit vector is 90, because if you take coordinate axis, okay, this as I cap we will consider, and this as j cap, y axis as j cap, and z axis as k cap. Clear? So if you calculate the dot product or scalar product between the I as well as j, then that angle between I and j will be 90. So that is why scalar product between two different unit vector, that may be I dot j, that may be j dot k, that may be k dot I, will be 0. Now finally, how to calculate the scalar product using the components. Using the components means we know that scalar product we will calculate between two given vectors. Here vector A and vector B. Between vector A and vector B we are calculating the dot product or scalar product. So instead of giving this, if he gives the vector A and vector B in terms of its components, we will split the vector given vector A into three components, which is Ax into I cap plus Ay into j cap plus Az into k cap. So this is how we will represent any given vector into its components along three different axes. Similarly, we will represent it for B. So in case if he gives the vector A in terms of its components along x, y and z axis, and B also he has given in terms of x, y and z axis. Now in that case, how to calculate the scalar product is, it is the product of vector A along x axis into component of vector B along x axis. Similarly, plus component of vector A along y axis into component of vector B along y axis plus component of vector A along z axis into component of vector B along z axis. So this is how you will calculate the scalar or dot product between any two given vectors if he gives the given vectors in terms of its